Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be discussing what's a very common problem on consumer electronics, and I first came across this problem in the mid 1980s on a Sharp video, and manufacturers are still making the same mistake today even all those years later. So let's take a quick look at this. It's a Yamaha amplifier I've had them for repair, and it turns on, but there's no sound coming out, and there's no click from this relay. That's the DC in the output sockets protection relay. Now usually there's two causes for the relay not clicking. Either one of the output transistors or both the output transistors have shorted out, or there's a power rail missing to the output transistors, which is actually what I've got in this case. So I've just drawn a quick diagram. So here, with the aid of this diagram I've just drawn, I'll show you the quick setup. So you've got AC from your transformer, goes into a bridge rectifier, it comes out as DC. This negative rail here connects to the negative of a capacitor, the reservoir capacitor, of which the positive of the capacitor connects to chassis. Now that gives us a minus 40 volt rail, or approximately 40 volt, I'm not sure what it is in this ham. And then the positive out of the bridge rectifier, that goes to the positive of a reservoir capacitor, whose negative pole is returned to ground. So there we get a positive and negative output. Now the reason my amp's not working is because I don't have a plus 40 volt supply. I've only got the minus 40 volt supply. This is missing. So if you look at that, what could go wrong? Well, you think there's only the bridge rectifier that could go wrong. But that's not the case in my my amplifier, and I'll show you what it is. Here we have two wire links that take the power from the rectifier to the capacitors. Now in my amplifier, this wire link is open circuit, and I know what you're thinking. How on earth can a wire link go open circuit? Well, let me show you this very common problem. Right, now I don't know how well you're going to be able to see this on, but I've also dug out a panel from a TV to give you a demonstration. So this is the problem here. It's caused by this glue, and if we go like that, you can actually move it along. So this glue, what the glue parts down, has actually become hygroscopic. It's moisture absorbing, and when you put some glue over a wire link or even a PCB track, it absorbs moisture over time, and it actually eats the track or the wire link away, and that's your problem. So let me just I can't get the camera in there very well, but I found an old TV board with the same problem that's going to be easy to demonstrate. And I don't know if you can see on the camera, but that is the wire link down there that's covered in glue. Right, so with the aid of this board out of an old Samsung TV, you can see the glue there, and when they put it on, it's yellow. But when it ages, it undergoes some chemical change. It goes hygroscopic. When it goes hygroscopic, it goes brown and very crispy. And you can see here this capacitor is glued to the board, but the glue's also fallen on these wire links, and where it's very brown there, it's actually eating away the copper of this wire link, and eventually that link will fail and it'll cause the set to fail. Now they put this glue stuff all over the place. There's some more on there. When it's a light colour, it doesn't do any harm. It's when it undergoes that change and it goes dark brown. So if we move here, you can see there's two resistors there glued together with some brown glue, and if we separate them, you can see all the glue's dropped off now. Now it's not too evident on the picture, but you'll actually see this copper, this top of this resistor, has actually been eaten away by this glue. Right, so you can just about see there, I've removed the glue, and that's the new wire link. The other one's just round the corner. Right, so I'm just going to show you this on my phone quickly because it's a better picture than my cheap microscope. when it comes into focus, but you can see there now, let's get this to point with, you can see where the wire links fail there, where it's been eaten away by this electrically conductive hygroscopic glue. So if you get anything in for repair that's got this yellow glue on that's turned dark brown and crispy, you definitely need to remove this, and bear in mind that when you remove it, whatever's underneath quite possibly will be damaged, so we'll need replacing. Now I've seen this glue over the top of the resistors, and when you take the resistor out it's open circuit, and I've also seen sometimes glue applied to, say, a wire that's going across a board underneath, and when you remove it you'll find the PCB track with the glue sat on top was actually eaten away in its open circuit. So yeah, and like I say, I first came across this in the 1980s, and manufacturers today are still using this exact same glue for some unknown reason. But yeah, that's your problem, guys and girls. So alright, many thanks for watching, and I'll catch you in the next video.